Hey, what's up YouTube? Welcome to another video. Today we're going to be talking about concurrency and what are weight groups. Just to preface, concurrency is the processes that you can run in parallel in Golang and obviously other programming languages like Java, C++, Erlang, etc. Multi-threading and concurrency is something that a lot of programming languages have. But you have to know that parallelism is not the same as concurrency. Parallelism is a process of running multiple processes at the same time, but concurrency doesn't necessarily mean that you're running process in parallel. It could also mean that you're running process sequentially and you're trying to synchronize these processes. Again, just to summarize, concurrency doesn't necessarily mean that they're parallel, but more often than always, you'll see parallel process running when you're using concurrency in Golang. And obviously, there's multiple packages and multiple patterns that you can use in order to organize your processes. So with that said, actually, let me do this thing quickly. So there was a little bit of there's still some blur here, but hopefully that'll be fine because I have the green screen. Anyway, so that's what I wanted to say about concurrency and parallelism. So we're going to start with weight groups, and weight groups are the most basic type of I guess I wouldn't say data structure. It's not a data structure, but it's one of the methods that Golang has natively in order for us or you as a programmer to coordinate your processes. An easy way to think about this is kind of like promise all rather than JavaScript being asynchronous and single threaded. You can use multiple threads in Golang and coordinate. Well, in reality, you're not truly coordinating process right here. These would be exactly multi-threads where you contain them within a group, and then once the group is done, then you continue your process to something else. So you can think of this kind of as a promise all, and within the promise all, you actually do have parallelism. So let's go ahead and start with some examples, and I'm going to try and incentivize some ideas here. So the first thing that I'm going to do, I'm going to do the following. I'm going to do a for I is equal to 0 as long as I is less than 10, I plus plus. Then I'm going to be printing I. And I'm going to be doing this 3 times. And let's change this to 10, this to 20, and this to 30. And let's do a time, so time dot sleep. We're gonna make a time dot second. We're gonna make the main function here to sleep for 3 seconds. So time second times 3, and I'm gonna put it here and here. By the way, so I create a concurrency package. I know that you can see here the declaration of the concurrency package, and I'm making also I created this variable weight group, which is using the sync.weightGroup library from Golang. And then I'm calling the function here in the main file. So just so you know what's going on behind the scenes, or rather than behind the scenes, just so you know what's going on the call execution in my main function. And then anyway, so we have that done. So now, as you expect, this is going to be taking 3 times 3, so 9 seconds. And if you want to do some time benchmark, you can do the following time dot now, And then at the bottom we can put and time.since, and then how long has it been since the start. Then format print, it has taken however long it has taken. Okay, so now I can go ahead and run this, and as we expect, this will take 9 seconds. So there's the 0 to 9, then the 10 to 19, then the 20 to 29. And it has taken 9 seconds, nothing odd there. So then let's say that you want to run all these processes. Obviously it can be something else that you're processing in parallel. That way, rather than taking 9 seconds, you could be doing this in 3 seconds. So what can you do? So you can put them in Go routines. So I'm gonna put this inside of a Go routine. Okay, so I'm gonna do the following. Well, actually, that's fine. Okay, so that's one. So go func. And that's my second one. And let's do the third one. Go func. And I'll explain a little bit all these things. And actually, I'm still missing. Well, we'll get there. But as you can see, so here I have, if I get rid of that, I have an anonymous function that is being invoked as I declare the anonymous function, right? Hence the parentheses here. And if I put go, then I'm making a Go routine here. So I'm making, I'm creating threads. You can think of this as threads. So let's go ahead and let's run this and let's see what happens. So it has taken 22, I believe it's nanoseconds. Did we do any work? No. Why? Because we didn't allow for the processes within the Go routines to actually do their work. So what can we do? One thing that we can do is the following. Add a wait group. So I'm gonna put wait add. Within add, the preferred syntax that I've seen is the following. It's putting the done right at the beginning. You put the defer. So this is like very clean. That way you don't forget that you have to put it whenever the Go routine is done. Now, mind you, you have to add a counter for every Go routine you want to be contained within the wait group, right? So hence why I'm adding a wait group counter per Go routine. Same thing, I forget to put the defer, wait group done. Same here, defer, wait group done. That should be done. There you go. And then outside of the Go routines, you put the wait group wait. And this is going to tell the process not to print. For example, let's say that I want to put format print wait group is done. So, and there you go. So this right here, this wait group is done, is not going to execute until the 3 Go routines are done. And that is very useful, because if you want to make sure that all these runs in parallel is done prior to whatever other process you want to run, that's how you use the wait groups, and that's why they are useful. Now you're gonna see something different, and that's totally fine. Let's see if we got this. Okay, they are running sequentially in this case, but let's run this again. Wait group is done. Okay, let me see something. Okay, so I rerun this. Just want to make sure, because this not, yeah, okay, yeah. So first you see the 20 to 29, then the 0 to 9, then the 10 to 19. So these are not sequential. That is something very important to have in mind. And again, it's kind of similar to the promise wall, you don't care which one finishes first. What you care is that you don't want to continue with other process until all of these are done. And that is what the wait group does. You're waiting for a group of go routines to be done. And then after that, as you can see, the print statement, wait group is done. So that is how you can run multiple go routines or process or threads in this particular case. Let's do the following. You can also run this obviously with functions. In case that you haven't seen this, I'm gonna go ahead and add this so you can have that that example with you. So this is going to be something very simple, but also it's something that you may see often. So I'm gonna create loop numbers or loop nums. I'm gonna pass the wait group as a pointer. I'm gonna put the init or the starting point and the ending point of the for loop. Instead of the for loop, I'm gonna put the following. I'm gonna put time.sleep, and I'm gonna put time.second times 3, which is kind of similar to what we had here. I'm also going to do the for loop, so for I is equal to init. Hopefully I didn't, yeah, I don't want that. To init as long as I is less than end, I plus plus, fp, I'm gonna print I. And I like to put the defer wait group done at the beginning. It's a little bit cleaner. You can put it at the bottom too if you put wait group done, but you know, it may be messier, so I like to always leave it at the beginning. That way there's no way for you to forget it. And that's it. Now what we can do now is, and sorry for the wiggling, that's just like the linter that I have, so try to ignore that for the moment. I'm gonna comment this out. So now what we can do is the following. I can do wait group add. So I'm gonna put 1 and then loop nums. I'm gonna pass the reference of the wait group, the init from 0 to 10, and I can replicate this, and I can also replicate that, and I can put from 10 to 20 and from 20 to 30. That way you're not writing the same thing multiple times. You can just write one go routine and I'm forgetting something very important. We need to put the go in order to make this go routines. And now this will work as before. So as you can see in the print statement, these are out of order as expected. They also took 3 seconds instead of 9 seconds. And then the other process was printed. So that is working perfectly. Now, something that you can also do, because it doesn't make, well, it's not that it doesn't make sense, but you can just do a wait group at 3. And that way, you know, it's just a neater way of doing the same thing. So, you know, this reduces a lot the code. Another thing that you can do, you know, I just wanted to show an example for something and somewhat a little bit more realistic, which is using URLs. Let's say that you want to ping APIs and you want to get responses. In this case, I'm not going to do responses. well, not JSON responses at least. We're gonna get the status code of the URL. So we're gonna be doing the following. So I'm gonna do func get status, where I'm gonna be passing the wait group pointer, similar to the other function, sync.waitGroup, and then I'm gonna pass a parameter of type string slice. So that is the one that is going to be containing the URLs of the, not APIs even. You can simulate as this would be APIs and how you would hit all the APIs concurrently. But in this case, we're just gonna hit URLs and get the status code. That's essentially what we're gonna be doing. So for each URL, I wanna add a wait group. And I'm gonna pass within my anonymous, I can create another function here, but since I'm trying to contain everything within the get status function, I'll write this anonymous function here and execute it. So, and I'll add something more in a bit. Yeah. So I'm gonna put the response and error is equal to the HTTP dot get, and I'll pass the URL. Error declared, not used, okay. Where's my Neil? I know that I have a Neil. I know that I have a key binding to write. Space EE. There you go. For error. Oh, should have known. Okay. There you go. So I just have a key map to write this. Very useful. I'm not gonna obviously just return error. So if error equals nil, I'm gonna just do a print statement. So f print, and this is gonna be a printf. So in the case that we have an error pinging that URL, I'm gonna say error. I'm gonna pass the string of the URL and point it next to why that URL did not give us a 200 successful status. Else, I just wanted to printf, not fprintf. Otherwise, I'm going to put, I'm going to show the status code. So this will be res and URL. Well, rest of status code. Okay, URL. Then here you see not enough arguments. So here, because we're creating this anonymous function right here with the parameter URL string, then I have to pass a parameter at the time of invocation. So that parameter would be the single URL from here, right? And that's how we would finish our Go routine using the anonymous function declaration. Also, just so we don't forget, again, I'm gonna put wait group done, so we don't forget to do that. And lastly, outside of this Go routine and outside of this for loop, I'm gonna put wait group wait. Now notice how within this function we're adding one wait group to however many URLs we have. So that this is another way of making sure that you don't have to declare, or you don't have to know how many URLs you have within that function, meaning you can pass n numbers of URLs and make this function dynamic, which is something that you may want to look for and something that may be useful. So here I'm just going to do the following. Well, first of all, I got to create the URLs, and actually I have this on my notes, so specifically the URLs, I will copy paste them. Actually, you know what? I'll just write them quickly. URLs. These are string URLs. So HTTPS, google.com. I'm gonna put Twitter. I'm gonna put YouTube, which you'll be watching this on YouTube. Don't forget to like and subscribe if you're liking this video so far. And what else do I have? Twitter, Udemy. Why not? URLs declared but not used. Okay, that's fine. So now I can do get status. I need to pass the reference of the wait groups and the URLs slice. And I don't have to put go here because that is already done within the get status. And just so you guys can see here, I'm creating my go routines as I iterate through the URL. So I don't need to put go here. That is already done within the function. So now I'm gonna run this, and do I have, like, I could even represent this. I could I don't know, I can put time dot sleep. I'm gonna put time dot second. I'm just gonna put 2 seconds, and if we have 4, that should be 2 times 4, it's 8. If it would not be concurrent, but because it is, it should only take 2 seconds. 1, 2. So okay, that's taking a bit longer. Okay, so that has taken 8 seconds, and that is not what we want, right? We want to make this concurrent. So let's go ahead and change this to make this concurrent, of course. And I committed a very small mistake here. I had the time to sleep outside of the go routine, so that is not going to be taken in account for multi-threading. Now this is within the go routine that we want to make this parallel processes. 1, 2, and now you see it takes 2 seconds, and I'm missing a new line somewhere here. Just so you guys can have this a little bit neater printed, or you can see this printed a little bit neater. Okay, there you go. So now you can see this, it took 2 seconds instead of 8. And you see that udemy.com, we got a rerouting or whatever, 403. YouTube and Google, we got a 200, and then we got an error for Twitter. So yeah, as you can see, this is how you can use wait groups. These are very useful, but not only they're useful, they're very basic for all the other concurrency patterns. So you're going to be using wait groups for mute access, you're going to be using wait groups for channels, and hence it's very important for you to grasp how to use them. I believe out of out of channels and mutexes and all the other patterns, these are the easiest. This library and this way to start concurrency in Golang is the easiest part. And yeah, next video we're going to be seeing channels. But yeah, if you like this video, give it a like, subscribe, and I'll see you on the next one. Bye.